Hi guys, sorry I can't be there today. I'm at a training, but we're gonna start our new unit. Our new unit's on similarity. So we're gonna start with dilations. Dilations are a form of transformations. You guys have done transformations before, like reflections, translations, and rotations. So this is the fourth type of transformation. So what a dilation is it's a type of transformation that changes the size of the shape. So it can make it bigger or smaller. So there's such thing called a scale factor with dilations. This is what makes it get bigger or smaller. So what it is, it's the multiplier used on each dimension to change one figure into a similar figure. This also tells you how many times bigger or smaller your shape will be. So we say it's a similar figure, not a congruent figure, because congruent means same shape and same size. So now it's just a similar figure because it's going to be a different size, but the same shape. So dilations use a scale factor to enlarge or reduce shapes. So the new shape and this should actually say pre-image, so just add that in there. The new shape and the pre-image are similar. And so dilations are also called similarity transformations. So how you dilate an object, first thing you want to do is you want to get all the coordinates of your pre-image. So you want to write the coordinates of the pre-image. And pre-image is the before shape, like the old one. Then what you want to do is you actually want to multiply everything by whatever the scale factor is. So the reason you multiply is because when you say, oh, it's 2 times bigger than it, you're literally multiplying everything by 2. And then once you have those new coordinates, then you graph the new points. So there's 2 types of dilations, where it gets bigger and where it gets smaller, and it depends on what your scale factor is. So the dilation is an enlargement if the scale factor is bigger than 1. And the dilation is a reduction if the scale factor is between 0 and 1. So again, if it's bigger than 1, it's literally gonna get bigger, because if you say it's 3 times bigger, and then if you say something like it's half the size, then that's when it gets smaller. So we're gonna do a couple examples together. So it says graph the images of the figures using the transformations given. So this is how you're going to see a dilation rule written. It has x, y, and then it says 2x and 2y. Basically what that's saying is you're multiplying all the x values and all the y values by 2. So you're doubling them. So what I do first is I write down one of the coordinates of the pre-image. So we have b. And that's located at -2, 2. And so I'm going to dilate that point by just multiplying it by 2, because that's what my rule is telling me. And now that is going to become b prime. If you've done transformations before, you should know what prime is. That just means it's like the newer version. So then -2 times 2 is -4, and 2 times 2 is +4. That tells me where the new point is after the dilation. So I'm going to graph it, and then I'll label it as B prime. And I can move on to the next one. So I have C, and that's at 2, 0. I'm going to do the same exact thing, multiply it by my scale factor, which is 2. And that'll become C prime. So that becomes 4, 0. And now I'll graph and label that one. And your next point, D, that's at 0, -2. And same thing, multiply both x and y by 2. And that gives you D prime of 0 times 2 is 0. -2 times 2 is -4. So then I go there. And that's D prime. And then your last one, point A, that's at -2, -2. So again, multiply both values by 2. And our A prime is going to be at -4, -4. So I go there. Yeah. Now I'm just going to connect all my points. And so if you notice, it's the same exact shape, it's just a lot bigger. And you could also tell it's being doubled because if you look at the distance between B to A, it's 1, 2, 3, 4. And then now in your new shape, it's 1, 2, 3, 4, 5, 6, 7, 8. It got doubled. So if your shape ever looks different after you did a dilation, then you probably did something wrong. So it should always look the same, just a different size. So let's go ahead and move on to this one. So same thing, you're just being asked to dilate it. The number that's in front of the x and y, that's your scale factor. It's telling you whether it's going to be getting bigger or smaller. So since this number is between 0 and 1, we know it's going to be a reduction, and we know we're making that shape a lot smaller. So I'm going to do the same thing. I can start with W. That's 1, 1. And I'm going to multiply both of them by 0.5. Which gives me W prime at 0.5, 0.5. So when you go to plot it, there's no half marks, but just try your best to see. So 0.5 and then W prime. And your next one is V at 2, -1. So same thing, multiply both of them by 0.5. So 2. That gives you 1. And then -1 times 0.5, that would be -0.5. So then you plot it at 1, -0.5. Again, just try your best to see where that would be. And your last one, point X. That's at -2, 0. And I'm going to multiply it by 0.5. And that'll give you X prime. This gives you -1, and 0 times anything is just 0. So now I plot it, -1, 0, and label it. Make sure you always label it so we know where's what. And then that little tiny triangle in there, I'll highlight it so you can see it. That's your new dilation. So you took that original triangle and now you just shrunk it in half. Hopefully this is making sense. Okay, so I'll do number 3. So our scale factor is 1.5. So since it's bigger than 1, that means my shape's gonna get bigger. So start at L, and L is at -2, 2. And I'm gonna multiply both of them by 1.5. And that gives me L prime, which is at -3, +3. So I'll put that, L prime. And the next one, point M, is at 2, 0. Multiply this by 1.5. 2 times 1.5 is 3, and 0 times anything is 0. So 1, 2, 3. And last one, point K, is at -1, -2. So multiply them by 1.5. Oh, duh. Wait, hold on. Oh, ignore me. 1 times anything is the same. My bad. Alright, then -2 times 1.5, 3. -3, yeah. Okay. Now, -1.5, 1, 2, 3, right there. So that's K prime. And then you'll connect them. And there's your shape. So hopefully this is making sense. It's really not too much. Literally all you're doing is just plotting points and multiplying. So I'll do one more. And yeah. Okay, so our scale factor is 0.25, known as a fourth. So since that number is between 0 and 1, we know this is going to be getting a lot smaller. It's going to be a fourth of its size. So start at D. D is at 0, 2. So I'm going to multiply it by 0.25. And D prime, 0 times anything is 0. 2 times 0.25 is 0.5. So I go 0, 0.5. That's D prime. Again, make sure you guys are putting the primes because that tells us that's the new point. That's how we know it's the image, and this one, that's how we know it's the pre-image. Your next point, E, is at +2, +1. So again, I'll multiply it by my scale factor, 0.25. 2 times 0.25 is 0.5, and 1 times that is 0.25. When you're plotting this one, just try your best to find 0.25. So 0.5, it's really tiny. So that should be good. Don't get a magnifying glass and make sure you're at 0.25. And then your last point, C, is at -1, -2. And same exact thing, multiply it by your scale factor. So C prime will be at -0.25. Okay, -0.5. So -0.25, super tiny. And that's C prime. So you should have like a super tiny little triangle in the middle. And so now you just took this triangle and shrunk it into a fourth. So that really is all there is to it for dilations. The back side of your guys' notes, that's what you guys are gonna practice by yourself. It really helps if you stay organized the whole time because then you can keep track of where your points are. So the back side and this front side, just make sure you guys turn it in before you leave today with the sub. Just turn it into your periods tray. And I hope you guys have a good day. I'll see you tomorrow. Bye.